All right. So as we talked about, right? So I mean, the previous discussion, what we had actually, we were talking about how the evaluation of overall collaboration, right, happened from the scratch, let's say. So initially we talked about the legacy wise, right? What used to be there in the legacy wise, like how the signaling protocol, right? Like the loop start and ground start, how basically wise used to get converted to electrical signal, and then basically what all were the challenges at that time, right? And then to resolve those challenges in legacy, we basically moved from analog to digital. In digital, the first limitation, it basically, um, let me just put it down here. So because we have discussed that, right? So not gonna discuss much, but then uh, so analog, right? So basically, voice used to get converted into electrical signal, right? And then we have digital, right? So this digital basically where voice gets converted to, the digital signals 0 and 1, isn't it? And then this is where we have signaling protocols. And then finally, we move from digital to, voice over IP, right? And the reason why we moved from digital to voice over IP, because somewhere in digital, plug and play, mobility, right? User interaction, that all it was not possible, isn't it? Um, in digital, basically, we used to have a PSTN and then we have a data, right? So in digital, it is still the all call will actually go to the PSTN, which will add extra cost to the company, right? Based on the number of calls. And so there is a resolution of basically all from digital to wipe, or I would say the features that we have brought in wipe, it is pretty much in high scale. So let me also quickly share the other video. I mean, just for your reference, let me quickly put it here. That basically covers some fundamental of, collaboration as well. Okay, so I hope you guys are able to see um, the screen, the slide, right? So this is what I was talking about. Why wipe is a big deal for the business, right? It is a big deal because first of all, reduce the cost of communication, right? Forwarding all calls over WAN connections rather sending it to over the PSTN, isn't it? Reduce the cost of cabling. That's again the number of cables that you do not require when you have wipe, right? Seamless voice networks using dial plan, all users can dial each other using 4 digits. So in analog and digital, okay, what used to have, you used to dial the complete number, like this number, right? Complete number. And there is terminology in collaboration, E.164. Is anyone aware of what is E.164 format called? Okay, no worries.
I've heard of the U law 711, but not
No,
8.164.
not. So this basically, E.164 is the complete PSTN dialable number. So this format means that number consists any dialable number that consists country code, national code, subscriber number, or country code, area code, exchange code, and then station code, right? So ultimately, this complete number 1602, where 1 represents a country code, 602 represents the area code, which is, let's say, country code US, area code 602 Arizona, central office code 555, and then end station code 1212. So this actually number is called 1P.164, means the complete PSTN dialable number, right? So in analog and digital, we used to have dialing based on all, 10-digit numbers or the 12-digit numbers based on the country, right? But in wipe, and this is something also you guys have to remember, right? Any dialable number, what does it, consist of? So it has country code, area code, station code, and then the station code, right? So this is what we were talking about. Take using 4 digits, isn't it? So you can actually dial the number in wipe using the 4 digits, where you can do certain digit manipulations in call manager. You can implement digit manipulations in the gateways, right? Where the users do not have to dial the complete number, but just 4 digit numbers, so the 5 digit numbers. In wipe, take phone with you, plug and play everywhere, right? So that again, it was not there in analog and digital. Soft phones were supported in wipe, but not in digital and analog, right? Email communications, voicemails, fax, that is possible in the wipe, but not others previous. Increased productivity, right? Voice extensions can forward to ring multiple phones, right? Like shared number or the broadcast numbers, right? So if you want to send, or if you want to ring multiple phones at a time, this is where it is possible in wipe. Feature-rich communication, voice, data, video. You do not have to now subscribe voice network for voice, for data network, and for video network. When I say what exactly for data, we subscribe what? MPLS and all, right? Data service provider. For voice, we have PSTN, and for video, we have ISDN, isn't it? But in voice over IP, one cloud only. You have to take just simple WAN connection, right? WAN connection will carry your voice data as well as video. That has combined, right? That is called actually the feature rich. Open compatible, standard different vendors can communicate here. Say in WIPE again, since it is voice over IP communication, right? So the different vendors also can communicate. Is it making sense, guys? So this is where basically we moved from analog to digital, digital to wipe finally, right? Um, okay. In this, in here, we have something called, you know, the infrastructure and design. So initially we will talk about actually whenever we are designing the collaboration or solution, right? What is required? What are their deployment offerings, right? In terms of the size, in terms of the bandwidth, in terms of the codec, right? So I'm sure basically you all are aware of what all codecs that we have, uh, right, in the collaboration, right? Habib, you just mentioned, no, that you mentioned EULA and MULA, right? So we have
Yeah.
certain codecs, right? What is the job of these codecs, by the way? In everyone is aware of that we use codec in wise, right? What do they do exactly? What is their job? Anyone?
They did the conversions of the communications, right?
Pretty much, yes. Converting from, so codec basically means coding and decoding,
Yes.
right? So coding as in from analog to digital and from digital to analog. That's what basically. So for that conversion, we need certain codec values, certain codecs, right? And this is where um, we have the different codecs that we have. Do you see that? Codec G.711, right? G.729, 726, 728. And then we have the bandwidth consumed, as in if you are using this codec value, what would be the bandwidth, right, required? And then if you are using actually um, any other codec, let's say G.729, right, what bandwidth is required?
Just sir, one question.
Mm-hmm.
Sir, as you mentioned, most of the technologies are now transitioned to VoIP. I see that. But I mean, I don't know. Why company still uses, maybe they are using old technologies. So as I last spoke, PBX and all. So the main the technologies which are there into analog, like electrical signals, still exist, I believe. Why I'm saying, because in with our customers, some of they are using elevator lines and this the emergency fire alarms and all. They are still running on analog, as analog
No,
phones.
what you're saying is absolutely correct. Okay. But I would still say, see, what technology or the thing what we have been using, right, from decade, those technologies would not just, go extinct, right? It will still be used, and there would be time where, the old technology is being migrated to the new technologies, right? This is where you may see there are still companies, very few companies, I would say, who are having still the old implementation, but that doesn't mean that they don't have the new technology implementation in their solutions. It is just that they are migrating it slowly. One thing, right? There are companies who have completely actually migrated from legacy to the newer technologies, right? Similar to um, similar to you guys might have heard about. I'm just giving some hypothetical, other actually some different example. You guys might be aware of the SD-WAN, right? SD-WAN technologies and all. So it doesn't mean that the WAN does not actually exist. It still exists, but the companies now who are actually, realizing that this is the next actually era, those companies are migrating from legacy WAN to the SD-WAN, right? Similarly, even in the collaboration technology also, unified, communications, companies are migrating to the wipe, right? But slowly, few have already completely migrated, few are still there. They're using the legacy one, but time to time they are migrating. That's what I can say. But now coming to, we always see the majority, right? You would hardly see the PBX and then the older technologies um, in uh, in nowadays, but it is not like you would not see at all, right? But more, I would say most of the time you would get to see the newer technologies, newer unified communication solutions. Does it make sense? So yeah, companies
Yes,
are
yes.
moving slowly. Okay, now talking about the shall we continue?
Oh, yes, yes.
So talking about actually but don't worry, from the exam point of view, okay, um, it would not be asked anywhere in the exams, say collaboration core or the CCIE. Okay, now talking about the codecs, as I said, right? So basically, um, the most important audio and video codecs which are used in Cisco collaboration, say CUCM, say WebEx, say Expressway or CMS telepresence or maybe SIP endpoints, right? So let's understand these codecs actually, for example, G.711, right? It is primarily we use it actually. We have a best practice of being used. I mean, this being used in the LAN environment, right? So most of the time in the LAN environment, you would see actually this codec is being used, right? And it requires 64 kbps to complete one voice call. So this is the minimum requirement. To complete one voice call, you should have the 64 kbps bandwidth available, right? Then you have the main opinion score, right? MOS. MOS actually, it talks about the audio quality. What is going to be the audio quality? Anything any near around 4, right, is the best quality. The lesser MOS actually will have the best quality, right? But up to 4.1 on and then below, everything is the with the good quality, right? Similarly, you have the G.729, which basically consumes 8 kbps, and then MOS is also pretty much good. Now you see here the bandwidth, because it consumes less. This is where this is the favorite codec value that we use towards the WAN side, right? Then
Yes.
you have the G.726 also, which I hardly saw being used. G.728, right? Which basically 64 kbps and MOS is great here. But then usually you have ILBC also. But usually you would see G.71 in the LAN and G.729 in the WAN. Other than that, you might have other non-Cisco, like you have Opus, right? That is also one of the codec value. You have AAC, right? LD, ILBC, we have just seen it, isn't it? So these actually codec values are used. Now, these are actually the audio codecs. Talking about the video codecs, right? So we have G dot, it is not here, but we have H.264, right? H.264 is basically for the video CUCM or the WebEx or the telepresence that supports that codec. This is the primary codec, video codec in Cisco collaboration. Which one? H dot, um, let me just put it here. H.264. All right. And this basically requires 128 kbps bandwidth basically to complete one voice call. Right. We have H.265 as well, right? That basically the newer endpoints they use actually this 265. Yeah, so that's basically the kind of video codecs that we have. I hope now This is clear as in what is used in the audio and what is used in the video. Okay, so let's get back to this. Now, let me see if anything pending there. Okay, well, I'll keep jumping between these two slides, by the way, taking as a reference. So, whenever you are actually designing or building the solution, right, the collaboration solution, you need to think from the design elements, right? What are their design elements? So as you see here, there are types of, the deployment what we have. We have on premises, we have hybrid, right? And then we have the cloud. Now, important to know what exactly the on-prem basically means, right? What does that basically mean as in the cloud? So see, I would say this, it is important to have idea about, what sort of deployment that your company is going to do. Because Cisco provides primarily these deployments, right? And each model has different architectural, operational, right, and integration design elements. So for example, on-premises deployment. So in on-premises deployment, what are the key components in on-premises? The key components are basically call managers, CUCM, right? We have Cisco Unity Connection, we have IMNP, MRA, mobile and remote access, we have contact center, right? We have meeting servers, isn't it? So that all basically comes, these all components actually comes under the on-premises, right? Where you'll have the full control of infrastructure, right? And they are installed in the customer's data center, right? Now, design considerations, it is always important. So whenever you are designing, what is the most important thing is the redundancy, right? So this is where you are going to have the CUCM cluster, right? CUCM cluster. We'll talk about the clustering and all, right? Then you have the SRST, SRST at the branches. We'll talk about that SRST when we exactly talk about the different types of deployment models, uh, on-premises different models that we have, right? Then apart from the redundancy on the on-premises, you have to also see the network QoS, right? Like CAC, DSCP marking, and etc. And then the other design consideration is the license, right? So like the different types of actually subscription, right? For the, let's say, flex subscription or maybe the named user models, right? So that's basically some design considerations when it is on premises. Now, when it comes to the hybrid deployment, it also offers, certain key components, right? For example, so hybrid combines actually on-prem infrastructure with, the Cisco, like the cloud involvement also. And when I say the cloud, I mean Cisco, let's say WebEx cloud services, right? So Hybrid basically means on-prem and as well as the integration with the Cisco WebEx, cloud services, right? This is where we have the hybrid calling, right? For the with the help of CUCM, which is there in on-prem, and then WebEx calling for the cloud, right? And then we have the cloud deployment, completely cloud deployment. So for the cloud deployment, we have the core cloud services that we have here is, again, the WebEx calling, WebEx meeting, WebEx messaging, right? We have contact center, right? WebEx contact center. For the management and analytics, we have the control hub, right? So again, we have these solutions offered in the or the major component which is there in the cloud deployment, right? So if I say the key components each deployment wise: on-prem, CUCM, CUC, contact center, CMS; hybrid, we have WebEx cloud; cloud, we have WebEx calling, meeting, and messaging overall, right? So now, with whether it is on premises or whatever the solution that you are opting for, these certain things are again the key point, right? So deployment offering, we just discussed. The sizing basically means um, how actually the size is you know uh, monitored, how you are going to calculate the sizing here. That is something important, right? So are you guys aware of any sizing, any tool which is there for the sizing and all? So see, we have certain tools, okay, which can be used to calculate the size. Okay, size in terms of the number of uh, you know the number of phones that you have, the number of users that you have, right? The number of phones that a CUCM can support. So when it comes to sizing, basically, let's talk about on premises only. So sizing means the CUCM sizing, right? So how the CUCM sizing depends on the number of users, number of endpoints, right? Codec type, cluster type, isn't it? What are their limitations? Like, for example, standard CUCM cluster supports up to 40K endpoints. How many? 40K endpoints can be supported in the CUCM cluster. And then if you have something like mega cluster support, which basically supports up to 150K endpoints, right? So again, we'll talk about that. Again, in on-premises, when it comes to the sizing, then you have to also see the Unity connection sizing, right? So in Unity connections, what do you think? What does that size means here? I mean, that basically depends on number of voicemail ports that you have, because each voicemail port will carry one voicemail, right? Between call manager and Unity connection, right? So typically it is between 24 to 144 number of voicemail ports at a time, right? Then you have the storage sizing also, right?
One question.
Mhm.
So when you said 40,000 endpoints. So does that mean 40,000 calls altogether, or like it's a different technology?
So 40,000 endpoints which can be registered with the call manager in a cluster.
Okay. And
Okay.
one more coming in my mind. So let's say customer having a PBX. So and it's how managing the circuit and all. So for those, one customer have a CUCM and one have a PBX. So both of them managing the same way. What the registration process happens in CUCM, 40,000 endpoints and all. Same design that we do for PBX as well, right, sir?
Pretty much same, yes.
Okay.
Pretty much same, but then PBX, when you have, right? So the PBX would directly connect with the PSTN. PBX actually would not, because it will have either the E1 or the T1 circuit terminating to the PBX,
Right, right.
right? So again, the number of calls that it can carry, that again it depends,
Okay.
right?
Company to company vendor and all.
Yeah, similarly in collaboration we have the cubes, right? We have voice gateways. So
Mm.
the number of amount of PVDM that we have, that defines how many calls can be actually, served at a time. So
Okay.
it doesn't mean when you have 40,000 endpoints, right? It doesn't mean that all 40,000 endpoints can call at the same time, right?
So one
Because
PDM card, how many calls it supports simultaneously?
So there are different types of PVDM. Okay, since you talked about PVDM, so let me actually. Okay, you see that. So first of all, those who do not know what exactly the PVDM is, right? So PVDM actually stands for Packet Voice over DSP module. Okay, and there is something called DSP actually, which is Digital Signaling Processor. Now, what are they and why it is required, right? So it is required because, see, let me just put it here. I just give a small kind of a topology, right? So let's say that's the switch, and then from switch we have the phone. Okay, this switch is connected to a router, and then you have complete here voice, CUCM and all. Let's say call manager, right? Now, this phone has 1001 and 1002. Okay. This gateway, this is the voice gateway. This gateway is connected to, let's say, your PSTN, and then it is also connected to WAN. This is your WAN, and this is PSTN. Okay. Now, see, when this 1001 communicates with 1002, the call would not go to the gateway, right? The request would go to the call manager. Call manager basically would send that call to this guy. But when now this basically router, right, is primarily, this voice gateway is primarily used for handling the data traffic, not the voice traffic. Now, if you want this, call to be, forwarded or sent to WAN or to PSTN, then in this router, you need to install the DSP, right? A separate processor, DSP, separate processor that will process the voice traffic. As of now, router is only capable of processing the data traffic, not the voice. If you want this router to process the voice traffic, this is where you need the DSP, right? Now DSP, it comes in the form of PVDM, right? Bundle. Inside of the PVDM, you will have the number of DSPs. PVDM is nothing but, if I have to compare, you all have seen the RAM, right? RAM which we installs in the computers or maybe the laptop. Similar size, similar actually, you know, physical appearance, I would say, similar way. The DSP modules are built, DSP chips are built in the PVDM, and then ultimately you will install this PVDM in the router. Now, how many the how many it does support, that depends on completely what PVDM you have. There are PVDM version 2, now it is PVDM version 3 also. Okay. So you see, if you talk about the PVDM version 2, right, you have 16. 16 means it can support 16 calls at a time where you have one DSP chip. PVDM 32 means there are two DSP chips, means it can support 32 calls at a time. Same 48, and PVDM 280 that has five DSP chips can support actually uh, basically up to 80 voice calls.
So, sir, we can say just another term maybe. So we can say that the gateway that passing the call from one station to another station outside, it can be cubed to certain environment. We call that cube, right?
Right. So anyways, if we have cube also, right? So cube is nothing but having that functionality, right, of handling the voice and video both, right? So nowadays, see, if you have complete voice or the video solution, then you would not have the ISR routers. Rather, you will have the cube basically with the again iOS functionality like iOS XEXR, right? That you can have. So if I ask, does cube, right, require PVDM to process the voice traffic? The
No, I think it's already inbuilt there, right? In cube.
Right. So actually, see, any session border controller, because cube actually is, the functions of the cube is as a session border SBC, right? So whether the PVDMs are required, that depends on type of the codecs or the call flows. Usually, in short answer, I would say cube may require PVDM, right? Again, depending on the deployment model. But in many modern SIP-to-SIP deployments, PVDMs are not required also, right? So you have to see basically, nowadays, basically, we have SIP-to-SIP, deployment and all, which is very most common, today. So if let's say your cube routes call between SIP trunks without needing DSP functions, right? So PVDM is not required, right? So no PVDM required when codec pass through, like both sides supports, let's say, same codec, because one of the functionality of the PVDM also is to convert device from one codec to another codec. If you don't have PVDM, you cannot do. So let's say if both the end you are using the same LAN and WAN, like same codec, right? You don't need. If you don't need transcoding, then you don't need PVDM, no conferencing and all, right? But if you are using different codecs, you require in that case PVDM, right? If you need transcoding, that require DSP or the PVDM. DTMF interworking and all, right? Uh, Call from, let's say, TDM to SIP or cube integration, you require PVDM. So again, the point here is, um, whether the deployment, whether you need the PVDM or not, that completely depends. But I would say where the PBX and other key systems and other thing exist, 90% PVDM is required.
Okay.
Okay.
Yeah, Abhi, a question.
hmm
So usually what happens is that the PVDM, is it provided by ISP, which supports the number of channels, like for example,
No,
PVDM2,
no. These
or
are the
we
hardware
additionally we have to
modules
purchase?
that every vendor, it is vendor specific actually,
Okay,
that you can have.
I see.
Yeah,
So,
we will have
so
this.
So there are different types of PVDM, okay? PVDM 3 series, right?
yeah,
Basically, that you can install it in ISR routers, 2900 and
PRI
3900
router
series. You
basically
have,
goes to PRI routers, right?
r-
2900.
right, you have PVDM version 4 also that you can install it in 4000 series routers.
Yeah. Okay. Okay. And when we, for example, if we install a PVDM2, which provides 80 number of concurrent channel of communication. So how would be the DID range of the deployments?
No, the
Like if you
DID
have,
range is completely different. There is no relation between the PVDM
okay,
and DID. DID
okay,
is basically when you are, getting the solution from the PSTN or getting connected to the PSTN. This is where the DID would act. You will have to purchase the DID range from the
yeah,
PSTN, and which you will configure in your cube or you will configure in your SPC or voice gateways.
okay, okay, fine. Just wanted to brush up that. Thanks.
Yeah. Right. So that's basically the sizing, same based on the sizing, you have the bandwidth. So why we are talking about all that? Okay, because see, it is important when you are the collaboration engineer, right? Today or tomorrow, you will work as a the solution design engineer. You will work as a the implementation. So these things make very strong point when you are offering any solutions to the customers, right? High availability, we discussed that you have the clusters and all clusters in terms of call manager, you have cluster in terms of in unity connection, you have cluster in IMNP, right? Similarly, you will have high availability in the cube or the voice gateways, right? The disaster recovery, which basically taking the backup and then restoring it, storing it back at the time of event failure or the new installation and all. You have the dial plan. So basically, again, we'll talk about, right? But then your dial plan again is very important in terms of how smooth solution that you're offering and how that overall communication that you want to make all smooth and user friendly and all. So dial plan, when it comes to the dial plan, there are two places where you can have the dial plan implemented. One at CUCM level, right? Two at the cube or the voice gateway, right? Then you have the security in terms of the certificates, right? TLS, OAuth, and all. So that's something again, which basically is the important part. But then we'll talk about this further. Okay. Now, any question from this slide?
Sir, maybe one. I mean, I'm sorry, I'm so I'm trying to connect the dots what we do, and so we also have a VoIP also, and this PBX old technology. Some of the customers are still using. So, if I understand correctly, so let's say for a customer having PBX, so that act as a CUCM, and what you said as a voice gateway can act as a PSTN, just to understand the infrastructure. Is that correct, sir?
You mean in PBX and kind of required element, wise to work?
Yeah, yeah, yeah. Yes, sir.
Okay. See, the PBX, yes, you can completely say the PBX in the legacy system is equivalent to your call manager, which is absolutely correct. What call manager does, when I say absolutely correct, means I'm talking from the call processing point of view, right?
Yes, yes, yes.
So you have actually, the PBX with the call control. And then don't I mean it is not like the PBX also does not support IP at all. Yes, it does support, you know. So there are three types of PBX also. Since you brought this point, we have traditional PBX where we have it is completely a TDM based. Okay. We have IP based PBX that basically supports the VoIP based voice over IP, like Cisco Call Manager and all that. And this is also the one of the reason, Piyush, why PBX still exists. Okay, because PBX also has that, the compatibility with the wipe, based, as well as it has the cloud PBX also. So the PBX itself is a complete solution, right? Cisco collaboration, is all complete solution, right? So it is not like the PBX would one day the PBX, because it's a different vendor, right? And they also come up with the different solutions, different advancement and all, right? So yes, for the core call processing, you have PBX, right? Then you have for the end devices, you have the phones, and then clients could be IP telephony like wipe phones, traditional, phones also. And then you have voice gateway, which is basically the SBC for external connectivity, right? Where you have the TDM voice gateways and all. So how we have the cube here, you have the voice gateway, like TDM voice gateway, right? And then similar to that, for the digital signaling processing and all, we have the media resources. So there also we have the similar kind of, architecture. And then obviously the PSTN, the gateway, or at the SBC, basically the main purpose of that is to, provide the PSTN or the SIP connectivity. You have also voicemail as well in the PBX, right? So pretty much what we have in Cisco, we have there also, and that is the one of the reason why the PBX is still, you know, not completely gone. Okay, hope that answers your question. So,
Yes.
the purpose of, describe the purpose of edge devices in the Cisco collaboration architecture, right? So let's also understand what are they, and then what is their purpose, all right? Obviously, we will talk about them in detail and in from the lab point of view also. But then the Cisco provides two main edge components. Okay, so we have Cisco Expressway, right? That is basically the core and plus edge, and then you have the Cisco Unified Border Element Cube. Right now, talking about the Cisco Expressway, the purpose in collaboration and then architecture, right? So you see in Cisco, one second. Okay. Okay. So this Cisco Expressway, right? You have mobile and remote access. So each component, or in this, the architecture itself, these are the main component in this architecture, mobile and remote access. What it does actually, the main purpose of MRA, it allows Jabber and Webex, right, app clients to securely register to, let's say, on-prem call manager from the internet. Any client which is there in the internet, and if they want to register with the call manager, this is where you need the MRA. You do not need the VPN here. Okay, the VPN is not required. And how the security basically is ensured here? The security is ensured, using the TLS, and then SRTP as a encrypted media. Right? You have the B2B video and collaboration. B2B means you have, it supports SIP and H.323 calls with the external organizations, right? Which allows business to business video meetings, like with the help of, let's say, WebEx or the SIP endpoints or the Cisco meeting servers. And you have the device registration for cloud services also, right? So you have Edge for like WebEx hybrid services, you have directory, calendar services, and etc. Firewall traversal, right? So the firewall traversal basically which enables endpoints behind the firewall, right? We have behind the firewall, or let's say the NAT, to communicate securely with outside endpoints. This is where you would require the firewall traversal, which you can deploy it in the Expressway. And then you have the use, like the traversal itself, it uses the, the port numbers and protocols to optimize for the collaboration traffic. Interoperability actually, as an, it works with the Cisco and non-Cisco video systems, uh, which basically supports the standards-based protocol. Now, what is the purpose of this cube? So the cube is a session border controller for SIP voice and PSTN connectivity. And the main purpose of these, edge device, the cube is the SIP trunking and service providers, right? So it acts as a SIP SBC between call manager and PSTN, right? Which basically normalizes the SIP signaling and handles the codec negotiation and media, anchoring and all. Secure wipe border, right? Which wipe border as an, it hides the internal network topology, which is not disclosed to the public. Provides security like DOS from the DOS protect, with the help of DOS protection, SIP message filtering, or TLS termination, right? That is why we have the secure wipe border, which basically ensures the security, right? You have media and signaling working different codecs, 0.711, 729, right? Works together, converts, uh, between SIP variants from various providers, high availability, as I told, box to box redundancy, maybe ISR or ASR, router redundancy, you know, and then call admission control and routing. So, like, it basically manages the bandwidth usage. If you this is one of the QoS kind of in collaboration, or in voice, right? Where it manages the bandwidth usage, right? Where it basically routes calls to the multiple carrier rather sending all calls to one carrier, right? Like something like load sharing and failover, right? So that basically this is where this CAC, is used. So yeah, any question from this slide?
Question, the mobile and remote access, it also registered through the cube or it has a different SBC?
No, it would register it from the cube itself. So when you say this cube, the obviously cube would be the part of it, but it registers directly with the call manager.
So cube will work as just as a SBC for the
SBC, yes.
there will be a six signal TLS certification and trunking and signal.
Right, that is correct.
Okay.
Okay, cool. So break time. Let's take some 15 minutes of break. Yeah, grab tea, coffee, or anything. So we will be back by it's 4:10. We'll be back by let's say 4:20, 28, 30, 4:30. Okay, so the next thing that we'll discuss is the describe the cluster upgrade process for communication. So any one of you have ever like upgrade the cluster or have you worked on this upgradation? Anyone?
I work on Avaya communication manager upgradation and patch etc.
Mm-hmm. Okay.
Many times from 7 to 8, 8 to 9, 9 to there is no 9 version, but 9 to 10, 8 to 10.
Right. So
Yeah.
ba
I've
basic.
also worked on the upgradation of version 10 to 12 CUCM Call Manager.
But this option, what is the meaning of cluster here in CUCM?
Right. That's what I was about to say. See, upgrading the standalone call manager is easy. Okay, it is very easy. But when it is cluster in call manager, what basically cluster is, let me just talk about, the cluster and then come back to this. In fact, yeah, since we are talking about some call manager stuff and also now we'll basically talk about specifically, okay, the call manager. Now, the call manager, as you are aware of, right? Primarily, these are the main functions that the call manager supports, right? So call processing, it is used for call processing, right? Then you have the signaling and device control. So when I say call processing, that would be for audio as well as video, both. Signaling and device control. Signaling means using a different signaling protocols, say SCCP or maybe H.323 or SIP, and then device control, right? So device control basically the call forward or the transfer or the hold and all that, right? The call manager also supports this dial plan administration. So we talked about the dial plan administrations you can do in two places, call manager and voice gateway. Phone feature, right? Administration. So again, we'll talk about that. Phone feature administration means particular setup of phones, what feature the particular phone should have. Okay, let's say this is phone. There are some default features like redial, all right? Like you can transfer the call, right? You can hold the call, you can park the call and all. So we'll talk about that. This is where you can, if you think as a voice engineer, if you think particular this department of all phones should not have transfer, feature available, right? Because they are not actually, supposed to transfer the calls, and also you can remove it like that. This is called actually the phone feature administration that you can do it from the call manager. Directory services, right? So when it comes to the directory services, the call manager will have a local directory, right? Local directory, and then it also has, for the directory services, it also uses the AD through the LDAP, right? So it also supports the directory services, programming interface to external applications, right? So the other external applications, Cisco, non-Cisco, all right, that it supports, that you can integrate those applications, includes a backup and restore tool like DRS, right? So these are the core features of any call manager that it can perform, right? Now, the call manager, right? How the signaling and media path works, right? Let's say there's both the phones, okay, phone A and phone B. If they want to talk to each other, what is the first thing that they should have is they should be registered with the call processing server, right? Now, to mention here, the call processing server, either you can have CME, you can have CME, or you can have CUCM. Okay. Now, what is CME actually? CME is a small call processing solution. Okay. CME is nothing but a router which is used for routing, right? And then later, company decides to implement IP telephony, okay, in this existing network. Let's say this router has, connected to switch, and then it goes to all endpoints here. That's how basically the, overall existing network is, right? And then this router is connected to, let's say, ISP and all. Now, company decides this is purely data. Okay, here we have the computers, laptops, servers, and all that, right? And then company decides, hey, why don't we have the IP telephony implemented to it? Anyways, we have, right? Or Cisco offers, hey, you have already built infrastructure, right? Data infrastructure. And just you can also implement IP telephony solution in your existing network without spending much. Okay. So what is the solution? They say, okay, this router anyways you load this router, okay, with the image that supports the voice also. Usually any enterprise or any universal image will support here. You have already phones, you have already, switch, right? So if it and ensure that this is the power over Ethernet switch, PoE switch, right? That it supports the uh, power over Ethernet. Simply buy the phone, connect to the switch, right? Buy the phone, connect to the switch, and then these phones will register with the CME called Manager Express, we call it, right? And then you have the voice functionality, IP telephone. If you want a little bigger solution, then have PSTN in it connected to it, right? So at least you will have that's a small solution, isn't it? So it supports this feature supports 450 phones, 450 phones in this solution that you can have, right? These are the iOS based router. Could be ISR, let's say ISR generation 2, right? We have 3900 and all that, right? That's called CME. So it has the similar functionality what call manager has. It has also voicemail. So along with the CME, you have the CUE, right? CUE. CUE stands for actually Cisco Unity Express. It's a separate module that you would install in this router for the voicemail, right? So you need to understand actually the overall architecture, right? So ultimately, within this small solution and with less expense, right, you have IP telephony implemented in the network, right? And then if you are upgrading your solution, then in this CME can also be integrated with the call manager and all that, right? So just to mention, I thought that okay, anyways, it should be actually covered this. Okay. We may talk about that, how the phone registration and all that it works with the CME. Maybe we can spend an hour in it, not to skip. Okay. So coming back to this. So other call processing server is your CUCM. Now, obviously, these phones would register with the call manager, right, using the signaling protocol. By default, it is SCCP, but any video phone, right, will support actually SIP as a signaling protocol. Now, when this phone wants to talk to this phone, right, so what happens actually, um, maybe to mention, right, so when you dial the number, obviously that dial number, right, through the SCCP or signaling protocol, call manager would gather those dialed number and see in its directory as in who is registered, where is. So if I ask you this question, let's say call manager gets the request that I want to send that call to, let's say this is 1001 and 1002. Okay. IP it has 1.2. MAC address, this is let's say B MAC address here, A MAC address here. This is 1.1 as an IP. So if I ask you, call manager gets the request to dial the 1002. Now, what reference it will take to send that ringing signal to this phone? One, will it take, will it check will it send the ringing signal to extension, which is 1002, right? Two, will it use the IP address, right? To, let's say, extension, IP address. 3, will it use MAC address, or will it use extension and IP to send the call? Anyone?
Extension and IP.
Must be like extension and IP as a form of URI.
Yeah, but you need the MAC address to be registered before you send the extension IP.
I kept it registered on the switch side. I don't know what the Cisco.
No, I
No,
think
but
when we are sending the call,
Like URL extension plus IP.
no, when we are sending, I think with the IP, the MAC address will be included because we are talking about layer 3 then.
that's right. On CUCM, if you don't register the MAC address, you will not, it has to be mapped. The MAC address should be mapped with the voice gateway in order to be, registered and then gain the IP address, and then you will be able to send.
Yeah, correct. And I believe we are considering this is already registered in CUCM.
But it is using SIP protocol. SIP protocol generally use URL like extension plus IP address or the DNS if there is domain name.
I think if they are registered in the CUCM, they can call with the extension, extension. Yeah.
If it's
So
already registered, then number
extension.
4.
So here extension means a device name. Okay, not exactly extension, but then
It's directory number,
the
basically.
device name. Yeah, device name. Okay, so the answer basically, phone to CUCM and then CUCM to phone, right? So phone to CUCM communication. Let's say if it is a SIP phone, it uses the IP address and plus SIP port number. What SIP port number it uses? So that
5060?
46.
5060 5061.
61, yeah.
And then if it is a CCP phone, then IP address and plus SCP port, which is 2000 and 2443. Now the CUCM manages the endpoints using the phone's IP address. Okay, so CUCM communicates to the phone using its IP address, basically, whenever it has to send that call to phones. Is it clear?
Yes. So it's registered with the IP address, right?
Right.
I have to understand the phone registration process. You have mentioned you will take one class, right?
Phone registration process. Yeah. It'll be the part of it. So we'll discuss sometime. Okay. Now, obviously, how basically other learns the MAC address, right? And all that is separate thing. But yes, let's say now this call manager sends the ringing signal to this IP. Okay, the phone is ringing. Phone, as soon as this phone answers the call, now what happens? There is RTP, okay, real-time transmission protocol. This RTP basically would be created between the IP to IP. Just remember, okay? So media path phones use RTP IP to IP. So after the call is set up, CUCM steps out of the media plane. Okay, CUCM is nowhere in the path, right? Media flows directly between phones to between phone to phone, or maybe between phone to gateway if it is going outside, right? During that time. Now, talking about the RTP, right? As in how RTP works, right? Uh, so, okay, I'll come to that. But then RTP session is established here. It is on top of UDP, right? It uses the UDP protocol. So UDP as a transport layer protocol, and then inside of that UDP, it uses the RTP. So this is where basically requires all the way source port, destination port, source IP, destination IP to actually form the session between these two phones. Okay. Once the session is established, this is where the media exchange occurs directly. Okay. Over this RTP session, there is, audio and video. Then the audio and video gets transferred. So in other word, how RTP works as in call setup, let's say SIP or SCCP, whatever it is, right? So before RTP starts here, okay, um, if they are using SIP or SCCP, that exchanges what? The codec. Codecs are exchanged, right? What codec they're going to use, the RTP port numbers, right? Now, obviously, IP address of each device, but no media, no actually media flows yet. Okay, that is required actually for the call setup. Now, this is where next is RTP session begins. So once, let's say, signaling negotiation is done in first setup, right, call setup, the phone A sends the RTP packets directly to phone B here. Okay. And then our phone B sends RTP packets back to phone A. Now, uh, what RTP packets contain actually? What is inside of that RTP packets? Okay. So it has a small chunk of digital audio, let's say around 20 millisecond. Okay. In it, it has the timestamp, as in when the call is initiated or the session is initiated. It has also the sequence number, right? And then the payload, which is compressed audio based, okay, on codec. Getting my point? And once this is done, RTP sent and received session is established, right? It has the jitter buffer also, which basically for the you can say the quality of service. So phone uses jitter buffer to smooth out the incoming RTP packets before playing them out as audio. Okay. So this basically jitter buffer helps removing choppy audio, voice drops, distortion and all that. As I told, RDP is UDP based, right? Because it is faster, no retransmission is there, right? Real time audio because it cannot wait and UDP is required, isn't it? Um, so in audio, as you know, if one packet is lost, you might hear a small click, but the call continues, isn't it? So that's basically how the RTP sessions are built. Now, can anyone tell me when RTP sessions are built between A and B, how many sessions will be built? Anyone?
I didn't get the question. Like, how many sessions? What are we talking? Like, how many?
So phone A and phone B both are forming the RTP sessions, right?
Okay.
So it is the unidirectional or bidirectional?
Bidirectional.
Bidirectional.
Like will in other word, will there be two session or one session?
One session.
Okay. So when it is communicating in terms of the RTP communication or the media flows, okay, there are two RTP sessions here, right? One RTP stream from A to B, like A sends wise packet, audio, let's say to B. This is one RTP session. Okay. The second would be B to A, right? This is the second RTP session. Now, two RTP streams, one in each directional. That basically makes it as a bidirectional. But whenever you capture the packet, let's say through the Wireshark, right, you would always see the two RTP sessions. So which RTP session you are troubleshooting, that is also important, right? So you have to see whether it is outgoing or whether it is incoming. Is it making sense?
Yes, 100%.
So ultimately, in other words, I should say one audio call equal to two RTP media streams. Yep. Now you may be thinking, why two RTP streams, isn't it? Why not one? See, voice is recorded and played independently in each direction. Voice does not echo back the same packet, right? Like how you sent ICMP and all that. So think this way. When A speaks, B hears. When B speaks, A hears. Right? So these are the two separate flows.
So it's basically a send and receive, right? It
Yes,
sends, yeah, it sends a packet and then it is received at the same time. So it will be bidirectional. So two streaming happening
that
at the
is
same
correct.
time.
That is
Yeah.
correct. Now this is about the audio. Okay. This is audio RTP. Now what about video? So how many RTP sessions in video then?
I believe in video it should be one only.
Go with the logic.
Well, eventually it has to send and receive, right? So I believe it's going to be the bidirectional.
So do you mean two?
Yes.
Okay. So what happens? Video means it doesn't mean that there would not be any audio, right? So video means audio and plus video. So ultimately two RTP streams for audio and two RTP streams for video. That means four RTP streams between A and B. Does it make sense?
Yes.
Yes, it does.
Okay, so there is something called, other than the RTP, there is something called SRTP, right? What? SRTP. SRTP stands for Secure RTP. Okay, so you may see this SRTP in implementation in most of the secure environment, and SRTP works almost the same as RTP in terms of sessions, number of streams, right? But in addition, what it does it adds encryption and authentication to protect the voice, right? So you can say this way, let's say SRTP between A and B here, right? So SRTP stream from A to B, right, which encrypts voice packets and traveling from A to B. B to A again encrypts voice packets, right? So total, how many SRT streams in case of audio only, let's say two, one per direction again, as I told. So it is not like SRTP increases the number of sessions, media streams or something like that. It works exactly like RTP, but yeah, uh, SRTP adds certain other features like encryption, authentication, right? Encryption again, it uses the AES 128 to 56 bit authentication, right? Which prevents actually tampering and all. Replay protection, right? Prevents replay attacks and all. Keying, right? Which basically delivered via the SIP headers or etc. So
So, sir, we keep hearing in our troubleshooting SIP ALG feature. So, SIP ALG feature is also in there in this only SRTP, or it's in through signaling.
now SIP is a signaling, RTP is media stream.
No, sir, SIP ALG.
Yeah. So I got it. Application, this ALG is nothing but the application layer gateway, right? So there is nothing to do with the uh, RTP here. That's
Okay.
different feature
Okay.
altogether.
Oh, sir, and one more question always in my mind when I started audio for last 3 4 months because I joined new. So,
Mhm.
sir, in TCP, because when we talk about voice calls, we always it's all on UDP.
Mhm.
So in TCP, one connection waits for another to respond and then stabilizes the connection. So let's say in any because of any reason, internet connectivity or due to any error, one audio stabilized call gets lost anywhere. So who takes the responsibility to stabilize again? Like what happens there?
See, it is the signaling protocol that you can use as a UDP or RDP. You can make signaling protocol, let's say SIP, right? SIP
Mhm.
to work as a either use as a UDP or TCP. That completely depends how you want that deployment, right? As you know, if SIP works as a UDP, then no acknowledgement and nothing, right? This is where sometimes we let's say fall back or we change the protocol from UDP to TCP to fix some issues. Where the TCP, as you know, it basically um, establishes the session and then acknowledgement and all, right? So this basically TCP or UDP, it is with the signaling protocols. Because audio
Okay.
streams you cannot use as a TCP, right? It is always a UDP. So there is no any option. But yes, how your signaling protocols behaves, that's something you can control, either UDP or TCP.
Okay, so their reliability happens on SIP. I think SIP signaling
Yes,
protocol. Oh,
yes. Because anyways, the SIP also will create a session, right, between the points, 2 points, isn't by sending the invite and all. This is where the session gets established, SIP. So that again depends. Okay, hope this particular slide is clear. Okay, so we were talking about actually I was about to discuss the clustering, but then yeah. Uh, so cluster actually. Um, the call manager, right? Clustering is nothing but the more than one call manager, right? That itself is called the clustering. Okay. Now this slide you may see little bit older, but then why I have kept it here, because it reminds how the technology started, right? And then, or it gives me the kind of ability to actually talk from the scratch about the history of call manager, and then starting continue to the to what we are using now. See, usually how call managers are installed earlier, right? Let's say the first call manager version, like 4 dot, it started with 4 dot, 5 dot, 6 dot, 7 dot, and this is where now it is 15 dot till 15.0, right? So earlier we used to install call manager in the servers, in Windows servers actually. Okay, in Windows servers till 6.2, right? Till 6.0, let's say 6.x. Then we started installing just to remove the dependency between Microsoft and then Cisco and all that. We started 7 dot onwards, 7.x. We started installing on a dedicated Cisco approved MCS servers. Okay, these are the kind of blade where you can install these call managers. But then here the limitation, one MCS server, one call manager, right? Like that. Or there are some other approved third-party servers also, like IBM and HP and all, right? That where we can we used to install. That went till 8.1, okay, and then 8.2 onwards, it started supporting the virtualization, right? So that's the overall history about how it used to be earlier. Now, basically, so it also supports cluster for redundancy and load sharing, right? So it provides data base redundancy by sharing a common database, provides call processing redundancy by call manager groups, right? So what cluster includes? Cluster includes one publisher as a call manager, one publisher. So total of maximum 20 servers that can be, right, can have. Okay. So total of 20 servers means what? It's not like 20 call managers, but it is nodes. And nodes could be your TFTP, could be media resources, could be conferencing, could be call processing servers in one cluster. You can have like, uh, you know, you can have media resources, you have application nodes, right? So 20, 21 total servers I have. Yeah. So basically, now coming to the call manager clustering, maximum of 8 nodes can be used for call processing. So 8 plus one publisher. In cluster, you can have 9 CUCM. Okay, you can have 9 CUCM, out of which one would be acting as a publisher and 8 subscribers. Now, subscribers only, see, subscribers, for the call processing, we can use only subscribers, where the publisher is used for the database, maintaining the database, uh, read write access to the database, where the Cisco would not have the read write access. Subscriber would not have the read write access to the database. Now, This cluster capacity, just remember, it also depends on the server model, the virtualization and all that, right?
So,
Okay.
sir, you said 20 nodes. So, eight of them uses as a subscriber, one publisher. So, subscriber for stabilization call, one for publisher for database. So, what others like 11 still left, right?
You have TFTP, you have media resources, you have conferencing and all that,
Okay,
the other components, right?
okay.
Now, when it comes to this subscriber, right? So eight subscribers. So how it works actually, eight subscribers, out of which four subscribers will act as a primary and four subscribers would act as a backup. We'll discuss that. But any question from this slide? Okay, this I'm gonna skip it by the way, just for your information. If you talk about the accounts in the call manager, there is something called root account and then common default accounts. So the default account anyways at the time of installation you will have two accounts, one for the CLI and one for the GUI, right? Which will have access to web admin and CLI admin. Now the root account you would not have access to any root account of the call manager. Okay, so who has access? It is the Cisco tag, right? Where they have the actually access to the this root account. So means you can create the root account when the password would be shared by them. Okay, and you see no access to native operating system debug interfaces and all. No direct access to this. Customer can activate remote account. Support for a specific time for Cisco tag case. Is it not like we cannot activate it? We can activate it, but with the help of again Cisco tag. Okay, how the database basically is managed. And so when it comes to the database, there are IDS database stores like static configuration and then dynamic configuration. What comes under the static configuration? You have servers and enabled services within the cluster. You have devices, phones, gateways, and trunks, user dial plans, and all that. That all comes under the static. Okay, then you have the dynamic also database, which is call forward, all, MWI, privacy, DND, hunt group login, and all that. That comes under the dynamic data. Now, how the database flows, it basically has a single master database model, means read-write database access only for publisher, right? And read only for the subscribers. So ultimately, what does that mean? It means any change, you can only make it in the publisher, right? And then publisher will push that data to the all rest of the subscribers. So the question is, can subscriber also make any changes? Yes, subscribers do allow read-write access for only user-facing features. Anything related to the user. Okay. So as a vice engineer, key point actually note here. So there are certain services which are only available in publisher. Sometimes what happens, we start looking at the subscriber and then we see this service is not available on subscriber, right? So if someone asks, hey, can you restart this service? Let's say, for example, LDAP sync. Now you as a vice engineer, maybe you log into subscriber and see LDAP sync is not available. So it will not be available because these services, what you see, it is only available on publishers, not the subscribers. So obviously, if the publisher fails, right, these services are gone or would not be available.
So we'll be getting this PPTs, right?
Yeah.
Oh,
Abhi, if the publisher is gone, so what will happen to the services and features and options which are configured on CUCM?
So services will continue to run,
Okay,
but if you want to restart the service, maybe some sort of troubleshoot and all, that's something not available, would not be available. So what you would usually, what we generally do if a publisher, let's say, is corrupted, right? So we have to rebuild the publisher,
hmm,
right? Rebuild the publisher. Then what about the database? Main thing is database, right? So
right,
because the database is replicated from publisher to subscriber also,
sure,
right? One,
yeah,
and then also the database, you can also take the backup.
sure,
So if you are pretty much sure that, okay, we have the, obviously, the subscribers would have the recent backup, isn't it? So you rebuild the publisher, right? And then push the configuration from subscriber to publisher. Now, very good question, actually. While fixing this replication, people do blunder, mistake.
yeah,
See, um, the database you can push vice versa from subscriber to publisher, publisher to subscriber. Okay. Now what happens? The blunder why I said, because let's say you rebuild publisher. Okay. Let's say customer rebuild this publisher. They're not aware of much, right? Uh, and then they know the process that, okay, we can actually, subscriber will have the copy of the database and we can put it back from subscriber to publisher. But the process that you follow, that is something important. You should not make mistake where by mistake you are replicating from, after rebuilding the publisher, you are replicating from publisher to subscriber, right? Because the process is pretty much same for both, right? What will happen if you are pushing it from publisher to subscriber? This blank copy will replace your entire database with the blank copy. This is where you should always replicate from subscriber to publisher. Is it making sense? Because there is a pop-up. Why, when you're doing it, right? There is a pop-up actually, which pops out, and then it asks for the confirmation. Do you want to override this or this or this, right? If you make a mistake on that pop-up, think the, the whole database is gone. Then there is only one way. If you have the backup, if you have, DRS, proper backup setup, you can restore that backup maybe to the publisher and publisher will push it to the subscriber.
so
So
the process of publisher backup to the subscriber, it happens automatically, or it has to be pushed manually.
it has to be pushed manually.
Okay,
Whenever you are building not only publisher but any call manager in cluster,
okay,
you have to push it manually.
okay.
Okay. And then obviously there is also a replication. See, these things are neither asked in exam, okay, the CCI exam and all, but these things are very critical for the working people who is working in the production, dealing with the CUCM upgrades, replications, clusters, and all that. right? So it is important. Um, it is important actually to know the complete process, right? So you have something called like utils replication, right? Runtime states that basically tells you the overall states. So you have publisher, subscriber, and all, right? Here, when you run this to verify whether the all subscribers are in sync or not, you can run this command, right? Utils db replication runtime state that basically gives you the value. Value as in there are actually three value that you can say, right? Or I would say two values. You would see two. Two basically means all good. Two is good. Okay, if you issue that command. You may also see 0 or 1, right? That basically 0 means it is bad, right? If you see 1, it basically means not sync at all. Okay. You would also see basically connected for each node. You have utils DB replication status that you can check, right? Just for the detailed information. So uh, basically, yeah, there are certain commands that works pretty much well, but then you should know. Now, what service actually is responsible for this database replication? There is service in call manager called the Cisco database itself. Okay, so anyways, I think this is something I can show it to you guys in the lab, right? That would make more sense, in fact, where you can see, and I have to build the cluster. Okay, no worries. What we can do is we can build the cluster, maybe one publisher and subscriber, okay, and then probably see the output, what it should be, right? Because when it is cluster, most of the time you you know face the replication issue, okay, and replication issue one, and then upgrade problem. Because in upgrade also, okay, in upgrade it is important because this is the first question I asked, right? How the upgrade works in the cluster. If it is standalone, it is all good, and it is easy process, right? But then if it is cluster, you need to ensure that it is basically upgraded properly. So what basically process is? Can we upgrade subscriber directly, or do we have to upgrade publisher? And how exactly? So see, whenever you are, because this is the part of anyway syllabus, right? So that is why we are discussing. Um, you see here, we have this describe the cluster upgrade process for communication manager, right? So CUCM cluster upgrades, follow as a publisher first and then subscribers in a sequence. That's basically the sequence. Okay, so publisher first, you need to upgrade the publisher first and then subscriber. Now there are two upgrade models that you can in place upgrade. what? In place upgrade, which basically, upgrade existing nodes directly. And then you have also parallel upgrade or side by side upgrade. So new cluster or on new VMs, let's say, migrate data. So, but what is the pre-upgrade task that you need to follow? I could have put it here. I think I forgot, or maybe because I wanted to explain, and that is why um, I did. Okay, anyways, I would update it later. Okay, let me share it again then. Resume, share. Okay. So to understand the pre-upgrade task, okay, anyone who performed the upgrade, can you tell me what exactly you check before upgrading? Which
By
is, yeah, go
with
ahead.
the backup version and what else? This one. Required patches.
Mhm. You said version. What else?
Backup. Oh, backup.
Backup.
Patches required or and phones firmware also if it.
Okay. So that all anyways, yes, it is correct. But when you are upgrading, you have to ensure that there is no replication issue. If there is a replication issue, the upgrade will ultimately fail. Even if you are following the correct process to upgrade, right, it will fail. Okay. So check with utils db replication runtime state. The value should be 2, right?
This
Yeah, Avi, just a question. We are planning to upgrade from version 12 to version 15.2. So our vendor has asked the what do you call it, iOS upgrade version of the routers, the voice gateway, basically.
Mm-hmm.
Why is that?
Maybe they want to parallelly upgrade the whole solution itself.
Yeah,
There is no correlation while upgrading the call manager, but I think the leadership wants to upgrade because usually this is how it works, right? Whenever the
right.
new release is introduced by the OEM,
Yeah,
we usually go ahead and upgrade to the latest version, right? Whether say it is gateway, say it is Unity connection, say IMP or call manager, anything. So
right.
that is anyways the best practice.
Okay, okay. Just wanted to confirm.
Yeah, so that's the one thing. Second thing, take backups, all right, using the DRS before performing the upgrade. Again, very important, right? From the ensure that you have call manager, IMB, and all that. It is backed up, by the way. The resource check is the third option that you can have. Resource check is nothing but check the CPU memory storage, which matches the version requirement, right? Um, like you can perform show hardware and show status and all. Also, you need to check the compatibility, like phone firmwares, whether it is compatible with the new version that you are installing. You can refer the data sheet and all. JTAPI, right? ISR wise gateways, compatibility, right? Certificates, what else in call manager? Local files and all that, right? And then after checking all that, you can go ahead with the upgrade sequence. Publisher, right? If you upgrading the publisher, the reboot is required, by the way, so it has to be done in the maintenance window and all, right? Uh, TFTP servers, which why I'm saying TFTP, sometimes publisher itself is acting as a TFTP server, but in your environment there is a dedicated TFTP server, right? Then you have to also after publisher you have to upgrade the TFTP servers, right? Because phone pulls new devices packages, right? And then third you can upgrade the subscriber. So this is actually the sequence: publisher, TFTP server, and then subscribers, and then other components like IMNP, Unity, and all that. Okay. So by the way, whenever you upgrade, right, there are two partitions in the call manager: active and inactive, right? So active means the current version, and then inactive means the uh, new version, right? So when you upload the file, that would go to the inactive, but then you have to switch the partition actually from inactive to active. And this is where we have command like software upgrade switch version. And this overall will take close to 1 hour, right, from switch over. Okay, and then follow the
Meaning that if the active version failed to operate, can we roll back to inactive and then bring it to operations?
yes, usually there is something called pre-staging, right?
Yeah.
So what does that pre-staging means? Even in the production also, you can, put the copy in the inactive version,
Mhm.
inactive partition actually, right? Once that file is in inactive partition, arrange the maintenance window and then switch the version from inactive to active partition.
Yeah.
Yes, you can roll back.
Okay.
This inactive and active are both in the same server or they're in the different servers?
Same server. So let's say you are
Same server,
upgrading
but
the
different
publisher.
partition.
Yeah, let's say you are upgrading the publisher, you will have two partitions, active and inactive.
Oh. In the CUCM server or the VMware server you are saying?
So CUCM, anyways, in the VM,
Provide.
in VM you have installed a publisher, right? So in CUCM, not the VM.
So Cisco have the option to keep the both file in the same server.
Yes.
Sir, one question in mind right now. So when we say subscriber, I heard some terms in SIP is SIP registrar server and all. So they all come under this subscriber.
See, SIP registrar is nothing but the call manager who is catering the registration request for the SIP endpoints. That itself becomes the SIP registrar.
Okay. So when we upgrade subscriber, all the features which are there for these SIPs, what I talked about, like SIP registrar, gets upgraded automatically.
Yes. Okay. By the way, this is the individual upgrade that we discussed. Okay. individual as an one by one publisher followed by TFTP subscriber and all. There is other also option you might have heard about, prime collaboration deployment, PCD, right? So that's basically a kind of automated upgrade, right? And you can also perform the upgrade from the PCD directly. But then PCD, in order the PCD to work, so how it works actually, in PCD you have uh, all the CUCM cluster nodes are added in the PCD, and then from here itself you don't have to log into the call manager actually. You just simply log into the PCD and then perform the upgrade from the directly PCD. Choose one node by node and then perform the upgrade. Okay. Also ensure the cluster version compatibility matrix also. Sometimes if there is a huge gap, let's say you're running 9 and then you are jumping to 14, something like that, right? The direct upgrade might not be possible, and this is where you need the COP file, we call it COP file, that would help actually, for the upgrade. So certain upgrades do not directly work. You need additional patch file. That patch file would make both the version compatible.
So the COP file can be arranged from which server in order to match both
Whichever
versions?
whichever you are upgrading, if you are upgrading in the publisher,
Okay.
right? So get the COP file, download it
Okay.
from the Cisco website and update in the publisher,
Mm-hmm.
and then follow the um, upgrade process.
Great process.
If you are following the upgrade process without this COP file, and in this example, let's say 9 to 14, the upgrade will not happen.
Okay.
Just an example, okay?
Cool.
Obviously, this is, these all are more into practical. But then because practicals and all, it is all time taking kind of. But then we have arranged a dedicated server to you guys where you can perform the installation, you can perform the upgrade, build a cluster, right? Spend some time and you can build your own lab. So that would actually give you a proper hands-on, pertaining to this upgrade and installation.
Great.
Right? Let's say someone is working on the so certain deployments, certain upgrades, and certain installations and all, right? So just to experience what all challenges that you face, so you should not face it in the production environment, right? Or in your working actually place, right? It is always good to implement it in the lab and then uh, do it in the workplace. So that is available, just for your information. So, and that is how anyways the learning goes, right? Okay, this is we already discussed. Database access control, as I told, whenever whenever actually we build the publisher and then build the subscriber, okay, there is, in order to have a secure, or in order to have a proper replication between publisher and subscriber, we, while actually installing any node, right, we need to set up the security password. Okay. Now, it is important to remember the security password and keep the security password same here, publisher as well as on subscriber. Then only they will, form the replication. If the security password is different, it is kind of authentication, right? So if it is different, they will not, the replication will not actually establish. And this is where most of the time you would contact Cisco tag saying, oh, hey, replication is, and this is what the first thing they do. They log into this and then check the security password hash value, whether it is matching or not. If it is not matching, they will suggest you to, you know, uh, maybe change the security password, whatever we have here. For that, obviously, you should know what password either here you have or here, right? And then change it, and then uh, once you change it, once you make it same, configure it same, it will form the replication. Or if you don't know the security password, maybe this was built 4 years back, and someone left who built this, right? And the data is not updated. In that case, you don't have any way to know the security password, right? In this case, the only option is to rebuild. This doesn't happen usually. I mean, things get updated, right? But then in hypothetical situation, we have seen, I mean, this also. Customer complaining, I mean, they don't know even the password, security password. They know GUI password, they know CLI password, but they never came across the security password and all.
So there is no way through CLI to reset the password on,
You can,
but
you
build.
you can reset the password, but then
Okay.
you have to reset it on whole cluster if you don't know.
Okay.
This password even cannot be reset by the root user.
No, no, the security password you can reset it, right?
Yeah.
I mean, see, what I mean is you will have option, okay, to reset the password, but for that you should know the password. Okay, what is the existing password? If you don't know and you want to reset the password with the new completely new password, then you have to do it in all nodes. Okay, because the security password is used for node to node trust, for the TFTP security, certificate generation and all. So it becomes important. If you are adding the new subscriber, right? That time also you need the security password and then same password. Just remember you cannot reset the password in subscribers, okay? Security password. So you can only reset the security password in publisher. So that means if you don't know something, right? Let's say you're building the subscriber and you don't know the password, what is the security password? Then what you can do max is you can reset the security password in publisher, and then when you are building the subscriber, right, that time you can pass the same password. Now obviously there could be certain there could be certain services that you need to also restart after the resetting, right? Based on, let's say, for the TFTP to work properly, TFTP service, Tomcat sometimes for the GUI access, DRF and all that services, you need to restart. Okay. the deployment and redundancy option. So whenever you are deploying call manager, okay, these are the 4 supported IP telephony deployment models. What is the time?
So this is always like that, like we have a backup for one PSTN and then IP WAN.
It is, yes. Usually how it works is for the inter-cluster communication and all the traffic would go through the WAN, right? Just to reduce the cost and all, because it is based on the bandwidth, not per call basis. If you are using PSTN as for the communication, then you have to pay a huge. So this why PSTN we have PSTN. So in case if the WAN is down, right, you can still make some emergency calls to the PSTN. And this is where you have to ensure that you have the, even not one WAN, but you have something like that.
And the process that you explained for this cluster, publisher, subscriber, and everything. So I'm just guessing for other vendors like Mitel, we have Shortel, PBX things and all. They manage their own things like that only, like somehow similar.
Yes, I mean, see, this process depends, on OEM to OEM. All right, same process
Okay.
would not be applicable to the other vendors.
Okay.
Cool, good, good interactive session, I would say. So yeah, I mean, we will stop it here, okay, and then continue tomorrow from the same topic. We'll continue tomorrow. Thank you for watching, guys.
Watching. Thank you for the session.
Thank you. Have
And
a great
same
evening.
same time, sir, right? Tomorrow.
It is